Hey, it's Miss Ballard, and we're doing Lesson 69 Math, Proper Form of Scientific Notation. Okay, so you should have already read the book, so this should be kind of review. So the question is, how do I make a number like this into scientific notation? It's really weird because you have a big number and you already have your 10 times something with your exponent. So we are going to pretend like we're just making this scientific notation and ignore this exponent right now. Okay, we're not going to worry about him. So we're doing this in scientific notation. I made 3 loops, so I would say this is 4.6 times 10 to the third, because I did 3 loops. Now I'm going to go back and I'm going to worry about this part that I crossed out earlier. And I'm just going to multiply it all together. When I simplify this, it becomes 4.6 times 10 to the 8th. Because I add my exponents, my 3 and my 5, so 3 and 5 is 8. Remember, I add exponents that I'm multiplying the base 10s. And that's my answer, 4.6 times 10 to the 8th. Okay, so next problem. Actually, this is example 1 in your book. It says write 25 times 10 to the negative 5th in scientific notation. Okay, so negative 5th means this is a small number, because it's negative 5th is an exponent, means it's 5 decimal places. Your decimal is 5 decimal places to the left. So we need to make our 25 right here into scientific notation. So what we're going to do is we're going to pretend our decimals right here. Remember, we assume our decimals at the end. And we're going to just jump one time, because scientific notation, we always have one number and then the decimal, whatever's left after that. So we get 2.5 times 10 to the 1 times 10 to the negative 5. Okay, the 1 comes from moving it one loop to the left. Okay, this is like saying 2.5 times 10, because anything to the 1 is the same thing. Okay, 10 one time, so 10. Okay, so now I have 2.5 times 10 to the 1 times 10 to the negative 5th, so I need to simplify this part. So I just bring my 2.5 down, my times down, and then I'm going to get base 10. I'm going to have a 1 and a negative 5. So with that 1 and that negative 5, I'm going to add them together, and I'm going to get negative 4. And my answer is 2.5 times 10 to the negative 4. All right, it's example 1. Down to example 2. Right, this time we're writing 0.25 times 10 to the 4th. Okay, so this one's a little weird because my decimal is before my number over here, right? So I'm going to stick to my guns and move my decimal where it needs to move one loop. However, did you notice that it moved right? Everybody else, when we did this, moved which way? Left. This one moved left. Okay, a left is going to give you a positive number, right? There's our positive 1. But this time I moved right, so if you move right, don't forget, that means you get a negative exponent. Don't forget, that's really important. Okay, so remember, right is negative if you move your decimal right. Oops. If you move left with your decimal, that's going to be positive. It's kind of counterintuitive, but just think about which way am I moving my decimal. Okay, so I move my decimal to my left. or this way, I moved it to the right. And let's see, now I'm going to get a negative exponent. So 2.5 times 10 to the negative 1 times 10 to the positive 4. And I'm looking at the exponents on top of my base 10. And I'm going to simplify these. So I get 2.5 times 10 is my base. And then I add negative 1 plus positive 4 gives me positive 3. And that's my answer. So that's a pretty simple lesson. All right, let's go ahead and do the practice set, okay? So on the practice set, I'm going to move this decimal one space to the right. And remember, we talked about earlier, if I go to the right, then my decimal, my exponent becomes negative. If I move my decimal to the right, my exponent becomes negative. So now I have 1.6 times 10. And I moved it 1 over, so negative 1 times 10 to the 6th. This gives me an answer of 1.6 times 10 to the 5th, because negative 1 plus 6 gives me positive 5. Okay, next one, 24 times 10 to the negative 7th. I assume my decimal is after this number, and I move it over 1 to the left, so it's going to be a positive decimal. 2.4 times 10 to the 1 times 10 to the negative 7. 2.4 times 10 to the negative 6 is my answer then. Okay, letter C. I have 30 times 10 to the 5th. I move my decimal over 1 to the left. If I go left, it's positive. So 3.0 times 10 to the 1, moved it 1 place to the left, times 10 to the 5th, 3.0 times 10 to the 6th. All right, letter D. I'm going to move my decimal to the right. Ooh, right. So if I move to the right, it's going to be a negative exponent. 7.5 times 10 to the negative 1 times 10 to the negative 8. I'm going to go ahead and add these two negative numbers with my base 10, and it gives me 7.5 times 10 to the negative 9. All right, letter E, 14.4 times 10 to the 8th. I'm going to move my decimal over 1 time. 1.44 times 10. I move it to the left, so it's positive. Multiply that by my 10 to the 8th, and that gives me 1.44 times 10 to the 9th. And last but not least, by letter F, I have 12.4 times 10 to the negative 5. Move it over 1 to the left. Means it's going to be a positive decimal. Moved it 1 hop, so 10 to the 1 times 10 to the negative 5. Simplify that part, 1.24 times 10 to the negative 4. All right,